Welcome back to our series on networking essentials. In today's episode, we're going to unravel the mysteries of TCP control flags and demystify the famous three-way handshake. If you've ever been curious about how computers establish connections and communicate over the internet, you're in for a treat. Let's start by understanding what sets TCP apart from lower-level networking protocols like IP and Ethernet. TCP is all about establishing connections for sending long chains of data segments. Unlike IP and Ethernet, which deal with individual packets, TCP ensures reliable data transmission. Now, TCP makes this possible through the use of 6 distinct control flags. These flags are like secret handshakes that computers use to communicate. But remember, their order isn't necessarily based on frequency or importance. The first flag we encounter is the URG flag, which stands for urgent. When set to 1, it indicates that the segment contains urgent data, and there's more information in the urgent pointer field. This feature is not widely used in modern networking. Next up, we have the ACK flag, short for acknowledged. If this flag is set to 1, it tells the recipient to examine the acknowledgement number field. Then, there's the PSH flag, which stands for push. When set, it prompts the receiving device to push buffered data to the application on its end. The RST flag, or reset, signals that a TCP connection needs a fresh start because it couldn't recover from missing or malformed segments. On the other hand, the SYN flag, or synchronize, is crucial for establishing a TCP connection. It ensures that the receiving end is ready to examine the sequence number field. Lastly, there's the FIN flag, which means finish. When set to 1, it indicates that the transmitting computer has no more data to send, and the connection can be gracefully closed. Now, let's put these flags into action with the famous three-way handshake. Imagine two computers, computer A and computer B, eager to establish a connection. Computer A initiates by sending a TCP segment with a SYN flag, saying, "Let's establish a connection. And here's my sequence number." Computer B responds with a segment containing both SYN and ACK flags, indicating, "Sure, let's establish a connection, and I acknowledge your sequence number." Finally, Computer A acknowledges Computer B's acknowledgement with just the ACK flag, saying, "I acknowledge your acknowledgement. Let's start sending data." This polite exchange is known as the three-way handshake. With both sides having sent SYN ACK pairs, the TCP connection is now established in full duplex mode. Each segment sent is confirmed with an ACK, ensuring both sides know what's received. When it's time to close the connection, a four-way handshake comes into play. The initiating computer sends a FIN flag, acknowledged by the other side with an ACK. If the other computer is also ready to close, it sends its own FIN flag, acknowledged once more with an ACK. And there you have it. TCP control flags and the three-way handshake explained in a nutshell. It's all about ensuring two devices speak the same protocol and can understand each other. If you found this video helpful in demystifying TCP control flags and the three-way handshake, please give it a thumbs up, subscribe to our channel for more networking insights, and hit that notification bell to stay updated. Feel free to leave your questions and comments below, and we'll be glad to engage with you. Thanks for joining us on this journey through the fascinating world of networking. Until next time, happy networking.